Hi folks, I want to continue our look at the different kinds of exponents right now. So I'll start by recapping what we saw in the previous lessons. Okay, so in particular, let's just do a little recall on negative exponents. Okay, we saw that the effect of a negative in the exponent is to give us, so x to the minus n is just equal to 1 over x to the, and now the exponent just becomes positive. Okay. Furthermore, we saw that exponent 0, so to round off the integers, exponent 0 always gave us 1, regardless of what the x value was. Okay, and we started to look at fractional exponents, in particular of the form where the numerator is equal to 1. And we saw that x to the 1 over n was actually equivalent to the nth root of the base x. In other words, this represents what number multiplied by itself n times gives you x. Okay, so in particular, the most common ones are square root or cube root, but you can have fourth, fifth, sixth, any root of a number. Okay, what I'd like to focus on now, though, is a rational exponent that doesn't necessarily have a numerator of 1. Okay, so that's what we're going to take a look at now, and we're going to see that we won't actually need to come up with a whole new way of looking at it. We'll be able to use what we already know to determine the meaning of those fractional exponents. Okay, so let's start with this example. Say I have x to the 2/3. Okay, so what I'm looking for is to find a meaning for this exponent 2/3. Okay, and I'd like to do that without having to come up with something completely new. So in order to do this, I'm going to remind us of one of our exponent laws. The third exponent law, the power of a power, says that if I have a power x to the m and I take it to the exponent n, this can be simplified by multiplying the exponents. Okay? Now, the other thing I want to remind us of is the fact that multiplication is what we call commutative, meaning the order in which we multiply doesn't matter. So this is equivalent to x to the n times m. But if I now apply the power rule again, this can be written as x to the n all to the power of m. So essentially what this tells us is if I have an exponent that can be written as a product, okay, I can apply either factor first. I can first take exponent m, then n, or the other way around. First n, then m. Okay, now let's see how that helps us with this scenario here. Okay, so what we're going to do is we're going to take a look at this exponent 2/3 and we're going to rewrite it as a product. I'm going to write 2/3 as the product of 2 times 1/3, which of course is the same as 1/3 times 2. Okay, so in other words, if I use this logic here that either of these are equivalent, when I look at x to the 2/3, I can think of it as x squared. So first consider this first exponent, all to the power 1/3, because 2 times 1/3 is equal to 2/3. Why is this useful? Well, because I know how to deal with exponent 2. I know what that meaning is, and I know what the meaning of 1/3 is. So this is equivalent to the cube root of x squared. Okay, but I have the other option of first considering 1/3 as the first exponent. So this can also be written as x to the 1/3 all squared. In other words, the cube root of x squared. Okay, so what I've managed to do is I've managed to find a meaning for this exponent 2/3 by writing it as exponents that I already know how to deal with, namely a positive integer exponent and a fractional exponent with numerator 1. Okay, so either of these are equivalent. The question is which one to use. So let's look at an example. Let's say for my example, I have 27 to the 2/3. Okay, so I have two options here. I can either write this as, so again, 2/3 is 2 times 1/3, so I can rewrite it as 27 squared all to the 1/3. In other words, the cube root of 27 squared. Or I can write it as the 27 to the 1/3 all squared. In other words, the cube root of 27 squared. Okay. Now I'm going to pause now, and I want you to think about which one of these would be the preferable one to use. Okay. So I'm going to stop for a second. I want you to pause, and I want you to think about which one you should be using and what the final answer would be. Okay, go ahead and do that. Okay, so we're back, and let's see what you came up with here. So if we take a look at this first version, if I wanted to calculate this, and say I was trying to do this without a calculator, here I'd have to first take the square of 27. That's a pretty large number that takes a certain amount of time to do. And then with this large number, I'd have to find a way to find the cube root. Okay, so we see that this seems fairly complex, because positive integer exponents make numbers bigger for the most part, at least when they're bigger than 1. Okay? Whereas if I look at the second option here, the cube root of 27 is something much, much easier. Okay? Roots tend to make numbers smaller, because the cube root of 27 is just equal to 3. And then all I'm left is with squaring a much smaller number. So I'm just left with 9. So if you were to stick this into your calculator, you'd get the same answer. But this gives us an indication that when we're actually trying to evaluate a power with a fractional exponent, it would seem likely that it's better to first take the root component and then the positive integer exponent. Okay? Now, let's say you're not actually calculating a power. Let's say you've got a variable there. Okay? Let's say you had x to the 2/3 as opposed to a particular number. So again, you have two options as we saw before. We have the cube root of x squared, or we have the cube root of x squared. Okay? So when we're not actually simplifying the expression, we tend to choose this one here. Okay, it avoids us having to use these brackets around it. Okay, so when we're just writing out an expression that we're not going to be simplifying, we tend to choose the version where first we're taking the positive integer exponent, then the root. However, when we're actually evaluating one of these expressions, we tend to first take the root and then the positive integer exponent. Okay, so you should take this note down following what we had last time. Okay, so here we've got the exponent, okay, which is any rational exponent. Okay, we know that rational numbers can always be written in fraction form. So this here can be considered in two ways. Okay, we either first take the nth root and then the power of m, or we have the option to first take the power m, the positive integer, and then take the nth root of that. Okay, these are both equivalent. So we'll just write ourselves a little note. This is usually better when evaluating a power. Okay, so for example, when we have 27 to the 2/3, and this, okay, is usually used when we're not actually evaluating. Say when we have a variable as our base. Okay. Okay, so usually used when the base is variable. Okay, so we'll stop here for now, and in the next video we're going to take a look at a few examples, and we're also going to take a closer look at negative exponents. Okay, that's it for now.